In this video, we're going to be talking about how to do a stoichiometry problem if you're not given moles and if you're not being asked for moles. Again, same as last time, you need a calculator, periodic table you will need for this one. You're going to need a writing implement, something to write on. Once you have all those things ready, let's go. Right, so the trick to this is that it's the same setup that we had for our last part, where the number of moles of what you're given times the mole ratio will give you the number of moles what you look for. That works regardless of the problem. It's just that here, since I'm not giving you moles and I'm not asking for moles, you just have to do a couple of conversions, right? So you convert into moles so you can plug it into the mole ratio. And then after you've plugged it into the mole ratio, you've gotten your answer in moles, you just convert it to whatever unit the question asks for. That's all it is. You just have to keep in mind what all of your different mole conversions are, whether we're talking about grams, molecules, atoms, volume of a gas at STP, volume of a gas not at STP using the ideal gas law, if I give you molarity of a solution, etc., 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 because we're going to keep adding to this as the year goes on. So know all of your mole conversions. If you don't, you're going to have a hard time with this. So we'll try a reaction right here, just combustion of methane. CH4 plus 2O2 yields CO2 plus 2H2O. And what I want to know is if we have 35.6 grams of CH4, how many liters or what volume in liters of oxygen gas at standard temperature and pressure is required to completely react with it. So why don't you guys take a couple of minutes, do the mole conversion, the mole ratio, then convert that to liters, and see what you get, and then pick the video back up once you think you have an answer, or you just want to see the solution. Okay, so we are starting off with 35.6 grams of CH4. Since we have grams, first place we want to take that is always to moles, so we're going to divide by the molar mass, so times 1 mole of CH4 over 16.05 grams of CH4. That will get us into moles. Now that we're in moles of CH4, we can do our mole ratio. I want oxygen, so 2O2 is going to go on the top. I'm trying to cancel CH4, so 1 CH4 goes on the bottom. That gives us moles of O2. The question wants us to be in liters. Now we have a couple of ways to get to liters of a gas. If we're not at standard temperature and pressure, we'd use the ideal gas law. But because we are, we can just use 22.4. Right? So times 22.4 liters over 1 mole. Cancel out all the units. We're left only with liters of O2, which is what we're looking for. And it gives us a final value of 99.4 liters of oxygen. That's a stoichiometry question. That is all there is to it. We're going to have plenty of practice with this in class. The next video, we're going to talk about what happens when I give you 2 starting amounts instead of 1. Right? So what happens if I give you the amount of CH4 and the amount of oxygen, and I ask you how much CO2 is going to be made from that. So I will see you guys next time.